Hi, this is Dr. Shafai, Dr. J, and I'm going to demonstrate problem 33 in your forecasting chapter, which is a seasonal multiplicative decomposition. We're going to use the average of all data method. Notice that here's the data, 4 quarters, 4 years. Here's the data. We have 16 quarters worth of information because 4 times 4 is 16. For one thing, let's realize that this is a time series. So if I were to actually put the time periods quarter 1 of year 1, quarter 2 of year 1, quarter 3 of year 1, quarter 4 of year 1, and then go on to year 2 and arrange the data in this fashion, you can see that this is all of quarter year 1, this is all of year 2, etc. So you can see that I really have a time series, and I can actually plot this just to see the shape of it. I'll do a line graph, and you can see that effect of the seasons in there. So what we're going to do is I'm going to delete that for now. What we're going to do is compute the effect of these seasons. To do that, you need to you need to first recognize that the quarters are the repeating factors each year. So your quarters are your seasons. So you need to compute quarter averages. So average of all of quarter ones. This is quarter 1 of year 1, of year 2, of year 3, of year 4. We want to know what is the effect of quarter 1. So if I compute that and I copy that down, these are my quarter averages. I also want to compute an overall quarter average, which is going to be an average of all of the quarters for all the data that I have right here. And that's 194.75. Then I'm going to compute my seasonal indexes. SI, or seasonal indexes. And the way to do that, I take each of my quarter averages, so quarter 1 average sales, and I divide it by my overall average. But because I want to copy that down, I'm going to fix the cell reference for G9. So I'm going to click key F4 on my keyboard to put the dollar signs in, and then I'm going to hit enter. Now whatever this is, actually, since if you were to replicate this with manual calculations, you would be rounding off to 2 digits. So let me just go ahead and fix this to be round. I want that round reported, but rounded to 2 decimals. So now with that formula, I'm going to copy that down, and I'm going to sum this up, and you will see that this goes slightly over 4. You would want your seasonal indexes to average. Seasonal indexes must average to 1. This does not due to rounding of seasonal indexes. So so you realize that. Now that I have my seasonal indexes, I'm going to add that, change that to red. Okay, now that I have my 4 seasonal indexes, I can see that season 1 is really a high season. It's above average sales. Season 3 is my lowest season. It's going to have the lowest sales of the year of all the quarters. So you can just go based on where the base is 1, benchmark is 1, and the relative difference between each of these seasonal indexes to 1 will give you an idea of whether it's a good season, it's a good quarter, or it's a bad quarter in terms of sales. So now that we have that, we can we must deseasonalize the data. How do we deseasonalize the data? Let me bring this over here. And to deseasonalize the data, I'm going to make this there. Okay, to deseasonalize the data, you need to take each of the, so this is deseasonalize deseasonalized data. All right. To deseasonalize the data, take this over. I'm gonna do that. Okay. So here we have our quarters again. 1, 2, 3, 4. And this is my years. Oh, let me move everything over above ones. There we go. Oh. 1, 2, 3, 4. I'm going to move this over up once. There we go. All right. All of these need to. Okay, so we have. Why am I doing that? My years are going to be here. Year 1, 2, 3, 4. And this, all of this is my deseasonalized data. All right. So I take each of the quarters and divide them by their respective seasonal index. So quarter 1, year 1, this value is going to be that number divided by its seasonal index, but I'm going to fix the cell reference. And that would be the number. Now, again, I'm going to, since if you were to do it by hand calculations, since you would be rounding to 2 decimals, I'm going to round that to 2 decimals. So you can replicate this at home. And that, then I'm going to copy over. So this one is going to be, you see over here, it's D5. So it's the quarter 1 of year 2. That is divided by H5, where H5 is this number right here. Okay, so which is a seasonal index for quarter 1. Okay, so then for this one, we're going to do the same thing. I'm going to round 172 divided by its seasonal index, but I'm going to fix the cell reference, and I'm going to round off that response. Oops, too few. Okay, no parentheses there. There we go. And I'm going to copy that. This one is going to be the 130. Oops, no, I want to round it off. Round the 130 divided by seasonal index for quarter 3. Fix the cell reference, comma, 2, close parentheses, enter. And I'm going to copy that. And this one will be the one, again, round 162 divided by its seasonal index. Fix cell reference, round off to 2, and then I'm going to copy that over. So these are my numbers, and these are deseasonalized. That means that if I were to, let me go ahead and copy these down. This is actual. Let me put here deseasonal, deseasoned. Okay, so here's Control C. I'm gonna come over here and just paste them. Control C, come over here and paste them as numbers. Control C and paste as numbers. And Control C and paste it as numbers. Okay, so this is okay. Yeah, so this is quarter 1, 2, 3, and 4 of year 4, which is quarter 1, 2, 3, 4 of year 4, which are quarters 13, 14, 15, and 16. Okay, very good. So now that we have that, I can go ahead and show you the graph for this. So here we have time periods 1 through 16, and now the deseasonalized data. And if I were to create a scatter diagram of it, you will see that all of those effects of the seasons are almost gone. Okay, so now that we have the effect of the seasons gone, we want to try and fit a trend line through this. So I'm going to right click, add trend line, and in here I'm going to set linear trend line is the default. I'm going to set display equation and display r squared. Actually, we probably don't need the r squared, but I'm going to do it anyway. And close. And now the results are right here. So my equation is, my regression or trend equation is, and I'm going to write that down here, my intercept, my slope are going to be written here. My intercept is 176.69. 176.69, and my slope is 2.06. 2.06, and I'm rounding. I could even go one more digit, and depending on how many digits you carry out your calculations. So that's my intercept, that's my slope. And now I want to extend this line into the future and see what would it be for quarter 17, 18, 19, and 20. Those would be 17. Actually, I can just do this. Okay. Oh, not that. 29. 7, 28, 29, 30, 31, 32, 30, whatever. Okay, so these are, these right here would be, year 5. These ones right here would be year 6. Oh, did I not do that? Let's see. Okay. Year 6, etc. So you can see that going down the line, these numbers right here represent our passage of time right here. Okay, so if I want to make an estimate or a forecast for year 5 and year 6, I'm going to have these, because these are my actuals, and I don't know what these are going to, oops. Okay, I don't know what these are going to be. These are my forecasts that I want to make. But I can say my forecast actually I'm going to put it, my trend forecast is going to be this deseasonalized number that has gone into this calculation and has created this slope. I can compute my trend forecasts using that equation. So my trend forecast is going to be for year 5 right here. Let me put lines around it so that it's easier to follow. Okay, so for quarter 17, which is quarter 1 of year 5, my forecast is going to be my intercept. And again, let me Control C. I'll follow that down. And this is going to be Control C. And I'm going to follow that down. So so my forecast is going to be equal to intercept plus my forecast, my slope times my time period, which is quarter 17. And actually I can just go down and copy that down. And these are my trend forecasts. I can actually do the same thing here and say the trend forecast for quarter 1 of year 1 equals my intercept plus my slope times the time period, which is 1, right? And I can actually copy that down this way. So all of these are giving me what forecast I would have made in the past for these time periods. So these numbers right here from here on out, which are in red, are forecasts to be made, and everything in black is numbers that we've had in the past and we're working with. And so but that's just the trend forecast. Don't forget that. Now, we did compute. Remember how we got this deseasonalized data? We got it by dividing. Remember this deseasonalized data that was used to create this line. We got these by dividing the actual data by its seasonal index. So we did a division to deseasonalize the data. When you want to re-seasonalize the data or put the seasonality back into it, you must reverse the mathematical operation. So seasonal or trend forecast with seasons can be given here, and that's where we take, actually let me put the seasonal indexes here first. So we have these seasonal indexes that I'm going to repeat. Oops. No. Something's not right. Oh, that's because there's a formula in there and I need to copy them as numbers. Copy them as numbers. And now I can take this Control C and Control V and Control V and just go down the line. Okay, and so I have several of them in the future. So these are my seasonal indexes, and my trend and seasonal adjusted forecasts are going to be what my trend forecast is. That, remember, in order to come up with this, I had deseasonalized data that went into this. So I need to put seasonality back into it. I had divided before to deseasonalize the data. Now I'm going to multiply by the seasonal index to put the seasonality back in it. So if I go down the line, Control C, Control V, and Control C, Control V. All right, so I can just get rid of these. I'll just get rid of this. There. So these are my trend adjusted seasonal forecasts. I can do an error analysis. I'm going to get rid of this to get more space. Now I can do Okay, so I'm gonna do a error analysis. Absolute error is actual equals absolute value of actual for time period 1 minus the trend and seasonally adjusted forecast, and that's my absolute error. If I compute all of them and average these, you can see that MAD is computed to be 5.1. If I were to let me go ahead and just quickly show you this. This was the actual. If I wanted to compute, let me add a trend line. You can see that the R squared, or coefficient of determination, is very, very low. That's the percentage of sales that is explained by passage of time. Now let's go ahead and do the same thing here for this trend adjusted and seasonality adjusted forecast. These are our good forecasts that we have made. And I would be comparing that against the actual. So this will be sort of like a regression where here is my actual and here is my trend. Oh, here's my actual and here is my, I want to know where I stop right there. And if I were to do another scatter diagram, but this time I don't want to do a line graph because it's going to be all jaggedy jagged. I truly want to have a scatter diagram. And if I were to put a trend line to it and display the equation and bring it over here, you can see, wow, 98.6% of your forecasts are, I mean, there's a direct relationship between your actuals and your trend adjusted. So your and your forecast. So these forecasts are replicating or resembling what the actual values were with a very, very high precision and accuracy. So this model is truly a good forecasting model for this time series. I hope you found this helpful.